Now, a structure is basically an assembly of components constructed in such a way that they act together to withstand applied loads and forces. So there you have a typical structure. If I'm not mistaken, I think that might be the Golden Gate Bridge in San Francisco, but it might not be. And there's another one, typical structure. We have that all around us. We have them in Brisbane, any major large city across the world. This, I think, is the Empire State Building in New York. So structural engineering, what's it all about? Structural engineers involves basically in the analysis of structures, where they are the derivation of forces, stresses, and also the deflections of the structures. They are also involved with the design of the structures, so they get to do the dimension calculations and also the selection of the material types. The purpose of them, the purpose of the engineer as a structure, to firstly ensure the safety, secondly the functionality, and also the economy under the most severe conditions during the lifespan of the design, whether that may be a breach, a building, or any structure. Structural analysis, what is it? It is basically apply the principles of mechanics to determine firstly distribution of load on the configuration, and secondly induce force in each individual member. Design part of it, basically to determine the combination of material and sizing for the members on the basis of the principles of strength of materials to ensure non-failure of the members, acceptable level of deformations, and also overall economy. Now guys, it is important to read through your study material. We won't have time to go through the slides on all the material in your reading material. So it is important. You will pick up on things there that you need to apply. We are basically going through the basics, and you guys do need to read up. So the available tools for structural engineers is basically computer programs, CAD basically, and it's also databases where they use material properties. Objectives, firstly to understand the classification of structures, secondly understand the types of stresses and the resistance mechanisms of structural members, understand the load types and the stresses and deformation that they cause, understand the principles of mechanics and their applications as well, and also to use tools to analyze statically determinate structures. Now, structure classification, firstly is the purpose or the habitation, industry of the transaction, etc. The shape and form, like vertical columns, horizontal slabs, trusses, beams, etc. And also the procedure of analysis. Is it statically determinate or statically indeterminate? Is it an unstable? Is it 2- or 3-dimensional, etc. We'll take a look at all these. The structural loads, if it's a dead load, a permanent or stationary basically. Live loads is temporary or non-stationary. Lateral loads is basically imposed by nature. You also get snow loads, thermal loads induced by thermal expansion, and other loads as well induced by handling, impact, foundation settlement, etc. Structures and the member stresses. We're going to take a look at the type of stresses, the tensile stress, compressive, which is tensile is basically actual elongation or stretching. Compressive stresses is basically actual shortening. Bending stresses, very important. We are going to take a look at the beam curvature. There's also shear stresses, and that's basically movement on normal planes. And then lastly there, the torsional stresses, which is basically a twisting action. Supports, we're going to take a look at the type of supports. There's basically 3 main types. The roller types, it basically allows lateral movement and also rotation. There's the pin support, allows rotation but no lateral movement. And then there is the fixed support type, and there's no rotation or displacement involved with this type. So there's two samples there. Basically, on the left-hand side, you have a typical pin-supported structure, connection between steel members, and on the right-hand side, you have a typical fixed support connection between steel members. So in each case, there will be certain reactions, and we'll take a look at those as well. So this is a typical roller-supported connection on concrete, and the one on the left-hand side, and the one on the right-hand side is a typical fixed-supported connection, also with reinforced concrete. So here is basically the reaction forces. Basically a possible support reaction in 2D, remember that. The first one that we had a look at was the roller. So you will have one vertical reaction force there. In the case of the pin, you will have two reaction forces there. There will be a vertical reaction force and a horizontal reaction force. And guys, please remember this slide is important. So I'm going to make you guys, I'm going to just select the pen here. Okay. I'm going to mark the slides which are important for you guys with a star. So this is something you're going to use in your assignment. So please print them off and print them separately and hold them because you are going to use them. As I mentioned, the pin support reaction basically have two forces, a reaction horizontally and vertically as well. Now the fixed one, and this is where it starts getting tricky. There's three reaction forces. The first one is the horizontal reaction, the vertical reaction, and there's also a moment reaction, a bending moment basically. So guys, this slide is also important, this one and the next one, all right? Because this will tell you basically the type of connection you can get, how you're going to symbolize it, and what the reaction is. This here, very important. Okay, so the type of connection, so you can see here, all right, this is the roller connections or rockers, but it's all classified as rollers here, and this is the type of reaction you're going to get. Okay, same with this one, also important, just to follow up on the previous slide. Okay, there's a pin reaction there, number 5. Okay, and you can see you'll have a vertical and a horizontal reaction on that, both unknowns. Okay, there's a slider reaction, and here you'll have a moment reaction starting to get involved. Fixed support, as I mentioned, this one is basically where you start having three forces, a vertical, horizontal, and a bending moment. And that's basically how you break it up.